Hi, welcome to Chapter 2, Section 4. As you can see, today is Chain Rule, Part 1. So first, let me just warn you, Chain Rule is a little bit complicated. I'm not going to lie to you. It's actually probably the most difficult section we're going to do all year. It's also called Part 1 because I'm splitting this up, because it's so difficult, into 4 days. So we're just gonna do so much practice with it. By the end of these 4 days, you're gonna be pro at Chain Rule. So I'm not trying to scare you off or anything like that, because you still have to do this. But I just want to reassure you, you're gonna be pro at the end of this. Okay, so first let's talk about when to actually use Chain Rule. The whole point of Chain Rule is for you to take the derivatives of more complicated equations. Let me give you an example. So if I were to ask you to find y equals cosine of x, this is something that we've been able to do, versus y equals cosine of 6x. So the 6x here makes it more complicated. Another example is if I were to find the derivative of y equals e to the negative 5x power, instead of just y equals e to the x. Because e to the x is real easy. The derivative is just itself. But once we complicate it with something in front of the x, that changes everything. Another more obvious example is y equals 2x plus 1 in parentheses cubed. So in the past we've been doing like y equals x cubed, but now like instead of x we have all this other stuff around it, the 2x plus 1. That's what makes it complicated. So here's what the chain rule is so that we can actually use it to find the derivatives of these things. So to use the chain rule, we're going to find the derivative of the outside, so like something cubed or whatever. You're going to leave the inside the same, and then multiply it with the derivative of the inside. So it's called the chain rule because you're kind of doing something like multiple times in a row, because, you know, like in a chain of events or whatever. That's why it's called the chain rule. So let's do an example using this. Alright, so I'm just going to use the equation that I was just talking about, the y equals 2x plus 1 cubed. So in this case, our inside is the 2x plus 1. And in general, it's like usually the stuff inside the parentheses. So that's like a really good way to tell when you would need to use chain rule. The outside stuff, so not including anything on the inside, would be like the cube. Okay. So following our chain rule then, to find the derivative of f of x, so we're writing it as f prime of x, this is going to be the derivative of the outside, leaving the inside alone. So the outside was my something cubed, so we would use the power rule to turn this into 3, because we would bring the exponent down to the front, and then the exponent would drop by 1, so it now becomes squared. Okay, leaving the inside the same would mean that anything that was inside the parentheses, the 2x plus 1, stays there. And then we're going to multiply that by the derivative of the inside. So our inside stuff is 2x plus 1. The derivative of 2x plus 1 would just be the 2. The plus 1, remember, is just a constant, so the derivative is 0. Okay, so I've applied the chain rule. I'm just going to simplify this out a little bit. So I'm going to multiply the 3 with this 2 at the end, and then the 2x plus 1 squared, and that's it. Okay, so not terrible so far. Let's do another example. This time I'm going to have g of x equals the square root of x squared plus 1. So first of all, I don't really like dealing with radicals when I find derivatives. I like to rewrite it using an exponent of 1/2. So this is actually going to be x squared plus 1 raised to the 1/2 power. That way I can use the power rule for it. So the stuff that's going to be on the inside is everything that's on the inside of the parentheses or under the square root. So that would be the x squared plus 1. So that would make the outside stuff the stuff raised to the 1/2 power. Okay, so finding the derivative. So g prime of x is going to be the derivative of the outside. So the outside stuff was the stuff raised to the 1/2 power. So I'm going to apply the power rule to it. So move the exponent down to the front of the stuff, and then subtract the exponent by 1. So this would make it a negative 1/2. And then the stuff on the inside stays the same. So x squared plus 1, that was on the inside originally, stays the same. Then we're going to multiply this by the derivative of the inside. So the derivative of the inside would be the derivative of x squared plus 1. So x squared the derivative would be 2x. The plus 1, again, it's a constant, so that would be 0. So I'm just multiplying all this stuff by 2x. Okay, so simplifying this down, and also I don't want negative exponents, so I'm going to rewrite that as well. So the 2x is technically over 1, so that'll end up being on top of the fraction. 1/2, so the 2 will end up on the bottom. And then the x squared plus 1 raised to the negative 1/2 power, because it's negative, turns it into the bottom of the fraction, and the 1/2 power would just be a square root. So if you want, you can leave it as the 1/2 power, or I like to actually write it as a square root, just to remind me. I don't know. I kind of reading square roots is easier, but finding derivatives of them, not so much. I also want to simplify this a little bit more because I can reduce, because both the top and the bottom has a 2 in it. So my final answer is going to look like this. I've got the x on top over the square root of x squared plus 1. Okay, next example. So this time I've got y equals 2 over x plus 7 in parentheses to the 4th power. So first, I see a fraction, so I'm like, oh, maybe quotient rule. But then if I look at the top, it's just a 2, that's just a constant. So it's not like there's an x involved or anything like that. So I actually don't need quotient rule. So here, I'm actually going to rewrite it so that I don't need the quotient rule. But I do see parentheses being raised to the 4th power, so I'm going to need chain rule. So I'm just going to write the equation as 2 times x plus 7 raised to the negative 4th power, because, you know, the negative just would make it into a fraction, and so I'm making it not into a fraction. So here we go. So here, my stuff on the inside would be the x plus 7, and the stuff on the outside would be the 2 with the stuff, the parentheses, raised to the negative 4 power. So when I find the derivative, in this case it'll be y prime because it was y equals, the derivative of the outside, I would take my exponent of negative 4 and multiply it with the 2 that's in front, so that makes negative 8. The stuff in the parentheses, and then the exponent would now be subtracted by 1 because it's going to drop by 1, which gives me negative 5. And remember, we're leaving the stuff inside the parentheses the same, so that would just be the x plus 7. Okay, then we're going to multiply all of that by the derivative of the inside. The inside stuff was x plus 7, so the derivative of x is just 1. And the derivative of the 7 is just 0, so we're just multiplying by 1. Okay, so multiplying by 1, I would end up with the same thing, so rewriting this nicely so that we don't have negative exponents anymore. It's just going to be negative 8 on top, x plus 7 to the 5th power on the denominator. And that's it. Okay, next I'm going to do one that looks really weird. So I've got e to the power of cube root of x. Blah. Weird. Okay, so for this one, my outside function looks like e to the x power, or e to the something power. Because the more complicated part is that cube root of x. So I'll use that as my inside. Okay, well, the cube root, again, we don't like the radicals, so let's just rewrite this as x to the 1/3 power. So when I find the derivative using the chain rule here, the derivative of the outside is just going to be e to the power of whatever, because it's the same as before, because e is that special one. So the stuff on the inside of the parentheses will still be the same, because we leave the stuff on the inside the same. Then I'm going to multiply by the derivative of the inside, and the inside is x to the 1/3 power, so I'm going to drop the exponent to the front using the power rule, and then subtract by 1 for the exponent, which gives me negative 2/3. Okay, so simplifying this out. Oof. The e to the cube root of x power, I'll leave that on top because I see I have a negative exponent, so we're going to rewrite that. So 1/3 would just put the 3 at the bottom. X to the negative 2/3 power would end up being a cube root of x squared. And it's going to be positive now because we've already put it at the bottom of the fraction. But this, and that's it. All right, one last example. So this time I want to find the slope. So we'll just mix in some of the old things that we also had to do, which was like find the slope at a point or write the equation of a tangent line. Those are still things you should be able to do here. We're just trying to use a more complicated way to find using the chain rule to find the derivative of a more complicated equation. So here we're trying to find the slope at x equals 2 if f of x equals tangent of pi times x. So first, let's find the derivative, because when we find the slope, then all we have to do is plug the x equals 2 into the derivative that we get. So for the derivative, my inside would be the pi x, because that's inside the parentheses, and then the outside would be the tangent. Tan of the stuff in the parentheses. And keep in mind, sometimes they won't write the parentheses when it's just like tan of something, unless there was like a plus or whatever at the end. So be careful of that. Sometimes the parentheses will be there, sometimes they won't. So finding the derivative, we're taking the derivative of the outside. So the derivative of tangent, that's one of those special ones. If you have it memorized, it's secant squared of the stuff inside the parentheses. Remember, the stuff inside the parentheses stays the same. And then we're going to multiply by the derivative of the inside. So the inside was pi times x. Pi is just constant, because remember, pi is just 3.14159, so it's just a number. So multiplying that by x, a constant times x, the derivative would just be whatever the constant was. So the derivative is just pi. Okay, so my derivative is just going to be, I'm just going to rewrite this so it looks a little nicer. Pi times secant squared of pi x. Okay, so now that we have that, we just need to find the slope by plugging in x equals 2. So pi times the secant squared of pi times 2. Okay, well, secant squared is really just 1 over cosine squared. Cosine squared, and 2 times pi is 2 pi. So cosine of 2 pi is 1, because 2 pi is really just 0. So cosine of 0 is just 1. Which will just leave me with a slope of pi. That's it for today. So we'll keep going with the chain rule just for more practice, but we'll add some more complicated stuff. But for right now, this is all I want to get to, so we get used to the whole finding the derivative of the outside times the derivative of the inside. Good luck. Have a good one.